Randolph Parker. Welcome to my channel, Randolph Parker MS. Welcome to my channel. So this is basically a 20 watt audio amplifier. However, the amplifier is performing better than anticipated, right? So mathematically, there were certain components I didn't have in my lab. I substituted them for other components. By doing so, I increased the wattage power. So right now I'm just doing a basic test with my Rigol load box, which is a great tool to have, or any type of load box to have. It doesn't replace knowing how to manipulate formulas mathematically, but it does give you a quick visual knowledge of what the components, what the circuit is doing. Again, I am a professional. I've been doing this about 30 years between IT, information technology, also electrical systems. My true background is more on the electrical side versus the IT side. I do have degrees. I started my career with the Rod Technical Institute back in the early 90s, graduated in 91, and then Thomas Edison State University with my associates in engineering, and my bachelor's degree in technical studies and electronics, and my master's at Southern New Hampshire Information Technology. And currently I am going to be pursuing a doctorate in business administration with a focus on information system at Liberty University. So with all that said, this is a warning. This is a safety situation where you're dealing with high voltage, high current, high wattage. In this case, it's supposed to be a 20 watt simple audio amplifier. However, when using the Rigol load box, the calculations that I calculated was little more than 20 watts. But let me show you. As I turn on the Rigol load box, hit on. As you can see, based on the Rigol load box, at 8 ohm load, I'm drawing about 3 amp current, and my wattage in this amp circuit is about 74 watts, and which is about 23 volts. So yeah, so as you can see, and remind you, the capacitor, the output capacitor I'm using is about 53 volts. So, in other words, I can't have this on too long without a fan. This output capacitor, coupling capacitor, is the last stage before the speaker. In this case, I'm using my load box as the speaker. It gets hot really quickly. So yeah, I do have little fans, but I wasn't gonna keep this on long enough. But just to show you how much wattage, my design was supposed to be 25 to 30 watts, and wound up being 76 watts output power, which is good for a single channel audio amp. But again, just gotta be careful, because you have to have the right component to absorb that power and voltage. So again, this is Randolph Parker MS, and this is actually part 3 of the 20 watt audio amplifier. I'm not going to go any further with this circuit, whether I break it down and put it on a perf board, or go through like a circuit lab type of thing and MATLAB and have a PCB. I don't think I need to. It's practical. You can use it. I can list the parts that I currently use to get it up to about 77 watts. If you're looking for something like that. Again, I don't want to leave it on too long, just because you have to have the right components. And when you're doing your math, you want to be within a 5 to 10% or 10% range tolerance, just in case, giving yourself a little more room, upper notch, where you give yourself a little more room where it's the cap can explode. You push it too much, and you don't have the right components. So again, it was designed to be a 20 to 30 watt single channel audio amplifier. It's actually 75 watt, which I'm happy because now I don't have to do any more math. I just gotta source those components that's currently on the board and tag it for later use. Again, this is Randolph Parker and Mess. Subscribe, leave a comment, and I'll see you soon in the next video.